Welcome to Future Bank Today, a community dedicated to driving innovation in our financial institutions. This is your host, Jim Kittredge, and today's episode is on cybersecurity and the influence of machine learning. I think it might be useful to begin by discussing how we protect our environments today. There are three basic methods which also happen to follow the evolution of cybersecurity. First, the perimeter of any network is protected by various types of hardware and software-based firewalls. These firewalls stop any unwanted traffic or malware from penetrating that network. They do this through various techniques such as whitelisting, blacklisting, detection, inspection, and rules-based algorithms. Secondly, banks deploy intrusion detection systems. In a nutshell, these systems provide monitoring of the environment, identifying potential issues at any given point. It also monitors transaction privileges to ensure a person or a transaction or a system actually has the authority to access or change any particular system. There are two basic kinds of intrusion detection systems. The first one is called NIDS, which is a network intrusion detection system, and it performs analysis of traffic on that network. The other type is called HIDS, or Host Intrusion Detection System. It operates on a specific host or server, and its main or primary purpose is to maintain full integrity of the critical system files, ensuring that they were neither modified nor deleted. HIDS is mostly reserved, though, for only mission-critical systems. And thirdly, and much more recently, cybersecurity has progressed to include a third model, which is called an intrusion prevention system. The best way to describe it is think of an intrusion prevention system as a combination of firewalls and intrusion detection systems, where they combine the best attributes of both of those methodologies. It's important to recognize that in today's world, while we have all of these tools, it takes a near army of human security analysts to constantly be monitoring and addressing alerts as they pop up. It is incredibly labor intensive and is getting more difficult with each year. One would think that we could potentially automate most of this effort, especially through machine learning leveraging big data concepts. This is exactly what the industry is doing with its rapid progression in machine learning. Imagine a world where a set of computers could monitor all the traffic on a network, ensuring permissions, ensuring policy adherence, inspecting every packet. It would contain all the known signatures of any attack. It is aware of existing system vulnerabilities. It self-maps all the environments and network patterns, and even could follow long-running transactions from end to end. And it can do this without an army of security personnel. This is the promise of machine learning. Sadly, however, contrary to the substantial hype from all the vendors, we are a long way from this. That doesn't mean we can't make progress with some highly focused innovation, which we should be doing, but right now, machine learning is not capable of reaching this utopic cybersecurity world. So what are the biggest challenges? Well, first is skills. We have a shortage of IT skills, network specialists, shortage of security analysts, and we have a significant shortage of data scientists that can work with big data. And most significantly, we have a paucity of machine learning developers available. The second biggest challenge is we do have current limits in our machine learning capabilities today. And although we used rudimentary machine learning in the 1990s to detect fraud in payments, one would think we could use those same techniques to detect anomalies in our networks today. While detecting fraud is complex in its own right, it's not 1% of the difficulty of a fully managed IPS. That is because there are only a few variables being inspected and acted upon in fraud detection. While the data volume is potentially huge, what specific data we look at is actually very limited. With today's capabilities in machine learning, fraud detection is a perfect use case. High volumes, limited complexity. As of right now, let's just say machine learning is not ready for an environment where there's 100,000 servers, each running a dozen or so software packages which each software package having 100 or more processes associated with it, connecting to dozens of other servers, being accessed by tens, if not hundreds of thousands of employees, millions of customers, hundreds of third parties, and more vendors than most of us can count. The average data center and network produces over 1 billion different transaction and data logs each day that are all unique. Machine learning is not ready for this level of complexity. The third challenge is we would first need to map out our world in terms of what is a healthy status of our current processes and connections, which of course is a lot easier said than done. Where would we even get this pristine environment? According to Verizon Security, nearly 100% of all of our networks have been already compromised to some degree. I often wonder if most executives realize the reality of that statement. The fourth challenge is scaling. I remember being amazed when I was a young architect working inside IBM's mainframe division, and I observed the ever-growing compute power it took to design the next bigger computer. It actually seemed more logarithmic than linear. I came to learn that the volume of information, and therefore circuit testing, did grow exponentially, in particular in comparison to the new platform's increase in size. This is a similar dilemma to what information security is facing today. And I definitely can see a day where more compute resources are dedicated to security than actually processing work. Just the cultural shift necessary to get to that point will be enormous. The last challenge is the problem of false positives. A good way to look at machine learning is to investigate how Facebook or Google uses it to serve up advertisements to a user. They are amazingly accurate 90% of the time. But 1 out of every 10 or so, you get a discount on a steak restaurant when you're searching for a leather jacket. Related? Sure, but not very useful. Now imagine getting 10% false positives across 1 billion transactions. Even if you think you can make the system smarter over time, which of course it will become, how do you manage through the process to actually get there? Suffice to say, false positives and to some degree, false negatives are machine learning's Achilles heel. So what's the bottom line with all this? Despite all the hype, I am 100% convinced of the value of machine learning in security. But as a good friend once said, there is no such thing as a silver bullet in security. So do I think machine learning can help today? Well, the simple answer is yes. With a focused, dedicated, and creative team, can do 3 things. First, they can help support security analysts with weeding through the incredible volumes of data. Secondly, they can develop processes that would automatically quarantine suspected payloads. And thirdly, they can help alert to any non-standard system behavior. Yes, today's human security analysts are more accurate, but it's not going to be too far in the future where machine learning will be able to equal them, if not surpass them. But first, we have to address those complexity issues. So today, I would focus on 4 organizations to investigate their offerings. The first is Cylance Security. The second is the MLSec project, which stands for Machine Learning Security Project. I would also look at the Apache Spark project. And lastly, I would begin to experiment with machine learning using Amazon's Machine Learning as a Service. I think those are all good starts. And if you really are convinced that you're ready for machine learning on a much larger scale, I would definitely consider partnering with Palantir. But before you do any of these, you need to address the number one issue in machine learning, and that is, do you really have the skills in-house? I mean, do you really have the data scientists and the machine learning experts to make progress in this space? And if you do, are they free to work on security issues, or are they tied up in marketing and product initiatives? And next week, we're going to change our subjects a little bit, and we're going to talk about innovation and the complexity dilemma. Thank you for your time today.